Welcome to Frank Teaches DevOps. All right, my lovely viewers. So today we will be talking about HPA. So HPA is horizontal pod autoscaler. So HPA is horizontal pod autoscaler. So this is a feature, it's an object, all right? It's an object of our Kubernetes cluster. In your Kubernetes, it's an object. So what this object does is, this object is responsible for scaling out and scaling in of your pods, right? So why would you want to scale in or scale out? It does this when, let's say, for instance, your application is having too much of a traffic, all right, where there is something somewhere, where there is too much workload. Maybe your application is receiving too much workload, all right. So, and if you have set up pod auto scaling, horizontal pod auto scaling, right, and you have set up a condition either on a memory request or a CPU request, such that that condition has exceeded its threshold, right? So the moment that threshold that you have set on that pod has exceeded, it will automatically scale out, right? Depending on the number of pods, all right, you have set the HPA to scale to, right? So let's, without talking too much, so this feature is used to scale in and out of your pods, right? Of your pods. This is achieved by setting a kind of threshold, maybe setting the condition. This is achieved by setting a condition, all right, on the resource level. On this resource level, we are talking about memory and CPU requests. Memory and CPU requests. Okay, so this feature is used to scale in and out of your pods, okay? Of your pods, which are deployed through deployment, okay? So this is achieved by setting a condition on the resource level, memory and CPU requests. So the idea is, like I mentioned, the idea, why HPA, right? Why HPA? Now, let's say, for instance, I have a web app. All right. I have a web app. And this web app only has, let's say, it has just one running instance. It has a one instance. So this web app has one instance. So this web app has just one instance. Now, this web app is receiving a lot of traffic. A lot. They play that thing now. Yeah. So this guy is receiving a lot of traffic. Sorry. So this guy is receiving a lot of traffic. So many traffic. All right. So these are traffic. Web traffic. Coming into your what? Your web application is receiving a lot of traffic. And like we said, you only have a single instance of this web application running in your cluster, right? Running in cluster. So a time will come, this application might not be able to receive these requests that are coming from the client side, right? So these are different web traffic coming from the client end. Right? So web traffic coming from the client end, okay? So a time will come, your web application will become overwhelmed because of too much of workload. So once it becomes overwhelmed, there's a tendency that the web application might either crash. Once it crashes, to stop displaying on your web browser, you might start having things like this web page is unreachable. All right. After some time, traffic has reduced. You try that same website, it comes up again. Now, if traffic still hits that website, the website will go down. Right? So this will be a continuous on and off process. Now, for we to be able to avoid such within the Kubernetes cluster, we will want to what? Leverage, make use of an object that Kubernetes has, which is what? Horizontal pod autoscaler. So now what's in this scenario, what the HPA will do, the HPA, whenever if you have set up HPA and you've set the conditions that now let me put it straight. Now, this is under HPA now. Now, I have my request. My request will be, so I have my resource. All right. I have the resource. So in the resource, I'm making requests. I'm making memory requests of, let's say, 200 megabytes. Then I'm also making what? A CPU request of, let's say, 50 millicore. All right? 50 what? Millicore. Now, somehow I have created, this will be my own deployment. Sorry. This will be my deployment. Okay. This will be my deployment. This will be part of the deployment, right? We've done a resource limit and resources. Yeah. So this will be part of the deployment. Then somewhere we have the HPA. We have HPA. Now, I want to use CPU as my benchmark. I want to set this threshold. I want to set the threshold on my CPU. All right. This is a condition now to be on HPA, such that whenever my CPU usage, this is on my deployment too, and my CPU usage for this application is what? 50 watts millicore. Now on HPA, I will set a condition that targets this deployment. It's going to target the deployment. Let's say somewhere here is targeting this deployment. It's targeting that deployment. That's deployment. That's when the CPU usage, utilization, it's called utilization. When my CPU utilization, all right, is greater than 50 millicore, I can put it in percentage. I can represent it in percentage. I can represent it as millicore. All right. So if it is, for instance, I'll say, okay, let's use percentage. Now, if I say it's greater than 100%, 100%, it will mean that my CPU usage has to be at what? Above 100 millicore. Because what I have here is what? 50. So for it to be 100%, that will be what? Times 2 of my current usage, right? Then that's cross. Okay. So once it is greater than times 2 of my current allocation, all right, please, the HPA should scale out. Now, the condition, this is the condition now. If this condition has been met, all right, then I'll set a minimum number of ports that should be in my cluster. That should be in my cluster should be what? 1. Then the maximum when this thing happens should scale to maybe 4, 5, 6, as the case may be. Let's say should scale to 4. So now with this condition at hand, what will happen is whenever this web application has received too much workload and the CPU usage has gone above the roof, has gone beyond 50 millicore, has gone beyond 50 millicore, all right, and it's getting to it's already on 100 millicore because I've said what? 100%, and it's more than 100 millicore. Please, HPA, scale my web application to more than 1. So now once this thing happens, you now see that I'll now have multiple of this guy. Wait, let me copy this. Okay. Now, once this condition is met, all right, I will now have an instance. I will now have HPA. HPA is going to replicate more instances of my web application. So I have one instance. second instance, third instance, depending on what I have set as what the maximum. Originally, I have it as what only one instance running. But the moment there is too much workload, too much of traffic hitting the web application, such that the web application can no longer handle, the HPA will come, will interject. All right. And it's going to what? Scale out. Depending on what I have set on what? On the HPA. It's going to scale out to the number of instances that will be able to what? To manage the workload. Then I will now have 4 of these same instance, this same web application running in my cluster. So it will be there until the traffic reduces. The moment the traffic reduces, it's going to scale in. It will shrink back towards 1. That is the function of horizontal pod autoscaler. Is there any confusion? All right, go ahead.
On your explanation of the percentage.
Okay.
When it's 100%, when it is 100%, when the
utilization, right, of the CPU is 100%, yeah. You can scale out, yeah.
So when it's 100% of 50 millicore, it means that
it's 100 millicore.
So what happens between 51 and 100?
It's because I've set 100%. If I had set 50%, if it's greater than 50%, all right, greater than 50, it means it's already there. It has gone, because to start from 0, 1%, 2%, the usage of 50 millicore, all right? So 50% of what I have. So once you get to 51 millicore, because it's greater than 50% what I have, all right? 100% is times 2 of what I have. Just like when they say they increase fuel price from 200 naira they buy to 400 naira. That's 100% now. That's times 2. They get me 100%, maybe half. You get me? Get a gist. All right. Now, let's look at, let's go to Google. All right. The same way we've been dealing with every other what's it called? Well, let's wait for this guy. Now, the same method we've been using for every other object. So this is what I will do. I'll come over here. Kubernetes HPA. All right. Enter. Then I'll go to their documentation, Kubernetes documentation. This is the documentation, horizontal pod autoscaling. Right click, open a new tab. Let's go there. All right. So you can read Kubernetes. This automatically updates a workload resource, such as a deployment or stateful set, with the aim of automatically scaling the workload to match demand. All right. You should just explain. Now, how does it work? So here it is. All right. So you have the HP already. And once there's high traffic, to scale the number of instances, pod instances that you have defined. Okay. So I'll share this link with you guys. You take your time and read. All right. Then algorithm details, blah, 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 blah. Go down. Stability of workload scales, clean during rolling, support for resource metrics. Now, this is now. Type resource CPU, targets, type usually. Let's see how it's defined. Let's see. Scale on custom metrics. Scale on multiple metrics. Support for metrics. configurable scaling behavior, scaling policy. All right. So let's see. Stabilization window, default behavior. So I'm not really seeing much. Limits, disable, support for the number of scalar in kubectl. Right. So there's nowhere this guy is defined as a manifest for this guy, right? So this is what we'll do. All right. We are going to use kubectl to manually set an autoscaler. Once we set that is up and running, then we will now expose the YAML configuration by doing kubectl get HPA, the HPA name -o YAML. All right, to get the YAML configuration. Then that's the only way we can be able to get an insight of what the YAML configuration of HPA looks like. All right, so great. So perfect. So this is what we'll do now. So let me go to my cluster. So this is my cluster. So I'll go to my Fitman, wherever, change my Fitman microservice. So in here, I will be targeting the API gateway. So if I go to the workload, go to my workload. So let me remove some of these guys. Where's that API gateway? So let me just copy only that API gateway deployment. Let me just copy that API gateway deployment only. Let me work with the API. Oh, yeah, it is. All right. So copy this guy. Let me check line number, sets NU. So I'm copying from 104. From 104 to this is that much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 26. Only mistake. 104 to 135. How many lines are there?
135.
31 lines. 31 lines. So 35 minus, is it like that? 35 minus 4. Okay, 31 lines, right? So I'll come here, all right? At that place now, I'll type 31 yank. YY. Don't forget to 31 YY. So below here, you tell me that 31 lines were about yanked, right? So, I don't copy them now. So I'll create a file called API gateway.yaml. All right. Then I will paste those lines. I press P to paste. Let's see if it's complete. It's not complete, guy. And the mathematics no sound though. All right. So we are left with the environment variable, right? Value is value. So save. I'll open the workload. So copy this guy. This is what we need. Copy, go to your API, then you paste that guy. Great. You're good. So I don't need limits. I don't need to put limits. I just need only resource block. So let's say this guy is 200 megabytes. Then this guy is what? 50, right? 50 millicore, right? So that's great. Then I also need to set up a corresponding service. --. So that will be escape, save and quit. So go back to workload. Oh, sorry, service now. Oh, Vim service, API gateway. This copy. So Vim API, then paste. All right, so I'm going to expose this guy as what? Node ports, then all right, 30,000. Great. Perfect. Escape, save and quit. So let's deploy, right? So kubectl apply -f API gateway, right? Great. All right, namespace is not found. So let's create a namespace. kubectl. Let me just put it in default namespace, needless of we going back and forth. Okay. So go back to API gateway. So I'm going to remove namespace. Remove the namespace. Remove the namespace. Escape, save, and quit. So kubectl apply -f API gateway. The pod has been created, right? So kubectl gets pod. Container still creating. Container is ready, right? Container is ready. Perfect. Now kubectl gets deployment. The deployment that we have is what? Fleetman API gateway. So that is the name of the deployment. All right. So now based on this deployment, we want to what? Create an HPA, a horizontal what? Pod autoscaler. Right? A horizontal what? Pod autoscaler. Remember that we've already defined CPU as 50 millicore, right? Great. So now this is what I will do. I say kubectl. Let's check for that help. Kubectl. I come on. Okay, create kubectl creates HPA. Let's look for help. All right. So let me see something. Create what? Is HPA here? It's not there. Ingress. I'm coming. 1 sec, guys. So kubectl is because if you use kubectl-h, you should see towards at the up deployment commands autoscale, right? So want to perform autoscaling. Okay. So kubectl autoscale, right? Let's give it a help. Dash help. So we are autoscaling the deployment. So let's see how it's defined. Let's go to the very top. Autoscale deployment, all right? Then the deployment name. Okay. The minimum number that you need is 1. The maximum is you define it. Then with CPU utilization. Now dash CPU percent is this. All right, great. So if we are using this method, copy this guy, paste that, right? So now say kubectl autoscale, all right? Autoscale deployment, then deployment name. Our deployment name is fleetman dash API dash gateway, all right? Dash gateway, okay? Then minimum instance that should be in the cluster is 1, all right? Then maximum should be 4, okay? Maximum should be 4. Then dash dash CPU dash percent should be what? 50 or 100%, right? It's in percentage, 100%. So I'll hit enter. So, okay, my spelling is wrong. Autoscale. So the moment you do that, to tell us that it uses a horizontal port autoscaler, right? So this guy has been what? Has been autoscaled. Okay, it's great. So if I now say kubectl get HPA, I should get, it takes the name of deployment, right? So this is the name of the autoscaler, and target is unknown. That's the usage so far. Then minimum port is 1, maximum port is 4. Replica, what we have currently is just 1. Okay, so great. So if I check it again, target is still unknown. Now, there is a command called top. We use top in Linux now. Remember, top is to look for processes, right? Resource usage, CPU usage, memory usage. You can still use that kind of command here in Kubernetes. But when you say kubectl top, then pod, right? So this is the syntax. It won't show you anything to tell us that error, metrics API not found, not available. So this top command works with the kube metrics server. All right, metrics state server. There's something called metrics state server. All right, metrics state server. So we're going to check that metrics state server. Are you getting me? All right. So not until this server is installed within your cluster, you won't be able to pick metrics of your ports. All right. So this is at low level, Kubernetes level of picking slight metrics like CPU utilization, memory usage, disk usage, etc., etc. So that is being crawled by the metric state server, all right? The metric state server. So for this thing to work, let's go to Google. Go to Google. We'll do the same thing. We'll say metrics server, all right? Hit enter. So let's look at the documentation for metrics server. So let's see if we have it. Resource metrics pipeline, metrics server. Let me see this. Do we have anything like that? Let me look at their GitHub, whatever, their GitHub repo. Let's see what they have there. Close autoscaler. Metrics pipeline. Let me see. Kube state metrics. Metrics API. This for mini cube. This for mini cube. I come. This is just measuring resource usage, metric server. To learn more about this, see the metric server repository. So let's check this repository. You should come into GitHub. All right. So let's see metric server. So let's see how to install this metric server. That's manifest. Let me check. Let's check. All right, installation. So this is it, right? So this is what you do. So this is where that's server is located. It's located somewhere here. So all you need to do, the metric server can be installed either directly from YAML manifest or via the official Helm chart. To install the latest metrics server release from the component.yaml manifest, run the following command, right? This is the latest. So this is going to give us the latest. So I'll copy this guy, copy it. Then before I run kubectl apply, let me just, let's see the content of that file. All right, let's see the content. So what I will do is I will just I'll just do duplicate of that guy. Right? I'll remove kubectl apply. Let me get it first and check the contents. Check the content. Duplicate. I think we've gotten it. All right, components. Let me go into that file, component.yaml. Let's open it. So this is it. API service accounts, cluster row, symmetric server, row binding. Okay. Service symmetric server. It runs on the kube system namespace. All right. Deployment metric server. All right. So that's all. So this guy is responsible for scraping metrics, right, within your Kubernetes cluster. All right. So yeah. So that's all. So this is all we need to see. Let's now apply it. So I'll paste that guy. Now hit enter. So it's going directly to my what? Kube system namespace. So I say kubectl get pod, right? In namespace, kube what? System. So I should have the metric state server. It's not up yet. The metric state server is not up yet. Let's try one more time. Still not up yet. It's taking some time. Take some time. Yeah. So our metric server is now running. All right. The metric state server is now running. So what I will now do is, if I now try kubectl top pod now, this command should work. Are you seeing it now? The command is now working because there's a what? A metric server that is feeding me the metrics of the pod, like the CPU usage, memory usage. You can see now, this is our API gateway. The CPU so far it has used is what? Just 6 millicore out of what? 50 millicore, right? Then the memory that skyrocketed, all right? I specified 200 megabytes. It is using more than 200 megabytes because there's no limit. I didn't set limits. If I had set limits, then I would be having issue out of memory, OM, right? I'll be having issue because API is using more memory. It's using what? More memory. So this is how you get your top command to work within your cluster. You get it to work by installing a metric server, right? A metric server must be up and running. So the metric server gives us insight of the metrics of what's happening within the cluster. All right, great. But so far, the kind of image I have used on my API gateway can never get me traffic. So I want to manually set traffic such that it will spike my CPU usage. All right. So for that reason, who will Abdul Rahman? Okay. Wale. So for that reason, I'm going to change this image. See, I'm going to change this image to performance. I'll change this image because this guy has some, all right, some, configuration that could spike the CPU usage. So I'll call it performance, escape, save, and quit. So I'll redeploy. I'll say kubectl apply -f API gateway. All right, great. So kubectl gets pod. It's recreating. All right. So it has terminated the old one and it has run the new one. Okay, great. So now, how do we check now? How do we check? So remember, get service. My API service is running on what? Port 30,000. Port 30,000. So this is what I will do. I'm going to say kubectl get port -o what? O white. That will look at the node that this guy is running on. This guy is running on 3.181. 3.181. So let's go to AWS. Let's look at 3.181. Is it you? No. Is it you? Yes. So copy this guy. Remember, we've not set the security group. Security, change security group. add Frank SG, add, then save. Okay, great. So here's the guy, copy, come to your browser, paste that, column, what? 30,000, 30,000. So this is my what? API gateway. Now, to access the aspects of, I want to trigger, it's like, it's a cost, a kind of, I'm simulating traffic, right? Because the image I have used has those scripts that could simulate traffic, right? So I'll now say /API/panic. Whoa. This guy won't change this thing. What's the problem now? Wait, let me see something. All right, let me inspect that image. Docker. I'm not gonna Docker for this machine. Oh, boom. Sudo yum install Docker. Let me inspect that image to look at the path that I need to target. Look at the path I need to target. Sudo systemctl restart docker.service. All right. So sudo user mode -ag docker ec2 user. All right. So I've added. Okay. New group.
New
I'll be bash.
No, just like
Don't work like this. If I do bash. All right. So Docker images. Yes, no, never sync. It's supposed to sync. Bash exit. All right. Now Docker images. You know, I see my new group. GRP, just like
Docker.
And Docker, eh? That's all. Okay, makes sense, man. Thanks, man. So Docker images. All right, great. So now let's do a pull now. Let's check that image API. So this image, I need to pull this image so I can inspect the image. So I'll say Docker pull this guy. So let's pull it and check the contents. So I'll now say Docker inspects, what's that image? Docker images. Docker inspects this guy. Let me use the ID. All right. So let me see where I can target. Let me see the path. If it's defined. This guy has modified his image. I'm not seeing it. Let me check the service. What am I not getting? Okay. kubectl logs, kubectl gets pod, right? And kubectl logs for this guy. Let me check. I don't see why I'm not getting. Okay. So API panic. Sub URL. So I can't get that. Let me change that image. Let me change the image. So go back to API. Let me change this guy to, let me see, which one is that? Is it resource? Comment out this guy. Resource, right? Escape, save and quit. Now kubectl apply dash F. kubectl apply dash F API. Great. kubectl gets pod. All right, it's a bad image. It's a bad image. All right, there's no image like resource. It's taking time to pull it. All right, so go back to API. All right, change this guy back. Don't need you. Undo. All right. Performance. So kubectl apply dash F. Got that. kubectl gets pod. All right. This is not coming up. It's supposed to come up. It's supposed to come up. Slash panic now. Okay, let me pause. So take note, guys. So it's so the simulation, the traffic simulation is under slash panic, all right, not slash API slash panic. It's just under slash panic. So now if we go back to our what, our cluster, and we'll say kubectl top pod. What are you saying? You're saying that our what, our CPU usage is more than 100%, Abi. So this is 300%. This is 300% now, or something 250 plus, but it's more than 100%. So at this point now, we should have some auto scaling. Now let's check. kubectl gets pod. So if I now do, can you see now? So auto scaling is now at work. All right. That's scaled to what? 4 instances, because the threshold was met that whenever there's a CPU spike that is greater than 100%, please scale. That's not scaling. Scaling now when you expand. Scale out and when you reduce. I think so. Scale out. No, it's the opposite. Scale out, comes back. Check it. Scaling, expands. All right. So this is autoscaler in action. All right. This is horizontal part of the scaler. However, we're not done yet. All right. This is scaling. Scale up. Scaling and scale out now. Scaling. Yes, now you see I'm scaling in, you're adding more. So it's opposite. It's not the way it's sounding. It's not the way it's sounding. So scaling, you're adding more. Scaling, you're adding more. Scale out, you're reducing. All right. And English, check them again, dictionary. Let's continue, guys. So now let's keep watching this guy and let's see. It will take some time for traffic to be reduced. So once the traffic lowers down, right, the workload reduces, the number of instances will also what, reduce until you get to what, to 1 pod of that instance. Are you getting me? Now, this is not where we need to get out. Where we need to get at is, we don't want this kubectl get HPA. I want to delete this guy, all right? Because you remember how we deployed this guy was through what? kubectl I want to create a manifest for this guy. So I will have a manifest. We've checked on what's it called? The Kubernetes documentation. We can't find any proper manifest. All right. So this is what I will do. I'll say now kubectl get HPA dash o what? YAML. It's gonna be dash o YAML. So I hit enter. So I'm going to see everything, right? So let's redirect this guy into a file called hpa.what? The YAML. It's now redirected. Now let's go into that HPA. Inside here now, I just need to remove some things. So items, API version, kind is horizontal port of the scalar, creation time, I'll remove creation time. Then the name, can remove this. We don't need that. Namespace is default namespace, even if I don't put it. All right, it's gone. Wait, undo. Just namespace now. Don't delete everything. Resource version, okay. UID can remove those guys, can remove these guys. Resource version can remove this. Can leave spec, okay. Now, maximum replicas is 4. That is when the condition is met, all right. The metrics is measuring is CPU, right? Metrics resource name is CPU. The target average utilization is 100%. The type is what? Utilization. The type is a resource. Now, minimum replicas is 1. Skill target reference. Now, this is skill target reference. The reference to what? To the deployment. We are targeting the deployment. Is still target reference. So the API is this. The kind is a deployment. The name of the deployment is Fleetman. That's okay. Then the condition, do we need to put anything here? Status, condition, reason, skill down is stabilized. Last transition time, message, recent recommendation we are higher than message HBA was able to successfully calculate a replica count from CPU resource utilization. Reason, value metrics found, status true, type scaling active, last transition time, message, too many replicas. I don't think we need these guys. So I'll remove this is just message condition, current metrics, which is this average current replicas for I think I can remove this guy as well. Can remove this guy. Current metrics. If I remove I'll remove current metrics. Remove these guys. Remove these guys. Remove. 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 Okay. The last transition time, can remove this guy. Remove, undo, okay. Remove, remove them like this. Status, remove all this, it's just a status. Remove. All right. So let's leave these ones that we have, right? So escape, save, and quit. Okay, now we have our HPA. So this is what I would do. I'm going to delete that HPA. kubectl. Remember when we say kubectl get HPA? We have it, right? Now, kubectl delete HPA. Then the name of the HPA is what? Fleetman API. So that's it. So once I do that, it's deleted. So if I now do kubectl get HPA, it's no longer there now. Now I can use the YAML file. So kubectl apply -f HPA, right? So let's see if everything goes fine. It's not telling me like that. Horizontal port of the skill are what? Created. Let's check. kubectl get what? HPA. So this is it. We're back, right? You're back. Great. So now kubectl top pod. So far, my CPU utilization is what? 3 millicore. kubectl get pod. Everything has come back to what? Normal, right? Great. Now, if I come here now, if I refresh this site, so while I'm refreshing this site, let's check our CPU usage. Top. Let's watch it. kubectl top pod is increasing 61 millicore. Watch you. It hasn't gone beyond 100% yet. 61 millicore. Let's keep watching. It has gone 1611. You see? So control C now. kubectl get pod. We should have the guys being scaled up. So guys, this is the beauty of auto scaling using what? Horizontal pod auto scaling. At this juncture, guys, is there any query?
Sorry, if the YAML file,
Mm.
if the can we develop a review without doing that?
No, why would you want to break your head to when you can just get it and just remove the unnecessary parts? And yes, you need to understand. Look at, there's nothing there. You just need to understand that the most important part, the API version, the item, these are the item, auto scaling. All right, scaling /2. The kind is an HPA. And the name of the HPA is Fleetman. And the spec, maximum replicas. You can always increase it, right? Minimum replicas. So minimum replicas, metrics, resource. The resource is targeting is what? CPU. The target is average utilization of that CPU. That's about 100%. And the type is utilization. Type is resource. Minimum replica, 1. 1 must be running at every point in time. All right. Skill target reference. You're referencing a deployment, which is this part. You're targeting that deployment. So whenever that deployment has traffic, it should what? Scaling. Any other query, guys? It's fine. That being said, man, I want to bring today's session to a close. All right. See you guys in the next episode.